Hello all, welcome back to my YouTube channel. So guys, this is video 2 of our machine learning playlist, and in this particular video we'll be discussing the types of machine learning. In a sense, you know the machine learning, right? But in machine learning there are different types. It is divided into the subtopics. So we'll be discussing about that in this particular video. And don't worry guys, whatever I'll be explaining in this particular video, this particular article, you will be getting this article link in this particular video description. Everyone can go through that. Let me tell you clearly, first of all, whatever theory will be there, we'll be providing the articles for that where you can go through clearly, and whatever collab notebooks will be there, we'll be implementing the code. That also links you will be getting. So just concentrate on the explanation what I am doing, and you can later go through all these things. You don't need to note down it somewhere. So machine learning algorithms are broadly divided into four major types. That is supervised machine learning, unsupervised machine learning, and semi-supervised machine learning and reinforcement learning. So in this, for the basic level machine learning engineer, supervised and unsupervised is mainly important, and semi-supervised and reinforcement, it comes later when you are going to the advanced topics. It's not an issue, you can learn slowly. So now let's discuss about this in detail. Supervised machine learning. Supervised machine learning is a type of machine learning algorithm where there is a labeled data set. In a sense, you will be having the both input values and the output also. So you will be just training the data. You have to, for example, if you have a data, okay, like company's data, you will be having both the input and what you have to predict the output, that also you will be having, and it will be in supervised. So you have to just train the data and split the output columns, and based on that you have to predict. That's all, nothing more than that. Hmm. So you can see here, supervised machine learning can be used for variety of tasks such as classification and regression. So classification is nothing but the algorithm is trained to predict a desired output, whether it can contain image or anything like audio or even the text data, anything can be contained, but only the desired output. For example, let's take there is a data set called as a heart disease prediction data set is there. So in that, what we will be doing, we'll be training the data where we'll be just predicting whether the person will get heart attack or no. If he gets heart attack, it is 0, and if he gets heart attack, it is 1, and if he doesn't get heart attack, it's 0. So it goes like that. We'll be training based on the data, and based on the accuracy the model also will perform well. So going further, you will understand this in detail. Just for now, just have a basic idea that in classification we'll be predicting whether it is yes or no. That's all. For example, you have ice cream, so you want to eat the ice cream or not? Yes or no? We will be predicting that. So So when it comes to regression, right? Regression is a type of supervised machine learning algorithm used for predicting the numerical values. So let me just give a basic example about that. You can read this in detail. So what regression does is it's like continuous numbers. You will be having continuous data, and from that you have to predict. Like, let me give you an example of, you all like cars and bike, right? So let's take an example of any car. Okay, you want to predict whether the car price or else the bike price. So there are different bikes and you want to predict the price of that. So that time it will be helpful because each bike will be having different prices and it will be varying, right? So it's a continuous data. You cannot expect like classification, yes or no is classification, but when it comes to regression you have continuous values. You cannot expect like a car price will be only this fixed price, right? There will be different prices and each day it will be varying the prices. So the model will be training on that. So the goal of this regression task is just to predict whether you are getting the price of that particular bike. For example, let's take an example of R15. So today the price is of 1,65,000. So you can just search for the model which we have trained, right? In that, if you give the input values like what is the bike name and the model, whether it's V3 or V2 or V1, and then you can say the location, at which location you want to check, and when you click on predict, right, it will predict you the price, it will show you the price. So this is nothing but a car or bike price prediction model. So based on these three input values, it will be trained, it will be previously trained. So based on these three input models, it will show you the price of that particular bike or car in that particular area. So you're getting my point for this regression. When it comes to classification, as I explained you all earlier, it is same. You will be just you will not be having the continuous values in the output column. You will be just having yes or no, whether you got heart attack or not, or else whether a person is eating ice cream or not. If he is eating ice cream, yes, the prediction is correct. If he is not eating the ice cream, prediction is wrong. You will be having some input columns. Based on that, you will be deciding. So when it comes to heart rate, heart attack, you want to detect also, it will be same. What is your height and what is your weight? Based on that BMI index and your sugar level, BP. Based on this, we'll get to know. We'll be predicting whether you have the chance of getting heart attack or not. Don't worry, we'll be performing the practical example, or else we'll be working on a real data set and we'll be making the predictions out. When it comes to the coding part, let us just understand the theory for now. And when it comes to unsupervised learning, only in supervised learning you have classification and regression. That's all. In unsupervised learning is a type of ML that involves training models to identify patterns and relationship between data without explicit guidance or labels. So when it comes to supervised learning, what it happens, you will already be having a input data and also the output column. So you can easily just train and predict the output column. But when it comes to this unsupervised machine learning, right, here you will be not having any labeled data or even any output column. So based on these particular input columns, you have to find out the output column. So this is called unsupervised. So let me just read out the goal for you all. The goal of unsupervised ML is to uncover previously unknown structures or relationship within the data, such as clusters, grouping, or anomalies. This type of ML is particularly useful for dealing the large amount of unstructured data, such as images, text, or sensors. So I'm telling you all right here, you will not be having any output column, like to predict any output column or anything. Based on the input column, it should predict. For example, you can take like there is a text, image, or anything, anomaly detection. So based on the input image we give, it has to perform the clustering, and based on the clustering, right, it has to group, and from that it has to take out the output column. Just understand for now, it's fine. Later I'll explain you all in detail when it comes to the practical implementation. When we use this type of ML, unsupervised algorithm are commonly used in a wide range of applications. For clustering the data, dimensionality reduction techniques will be using in PCA. There is something called principal component analysis, PCA, which is very important. That will be using the unsupervised ML only. We'll be discussing more about that, and which helps us to make the key decision and the streamlined process. So there are types of unsupervised ML as well. Again, there are four types. It's divided into four subtopics. One is clustering, then dimensionality reduction, then anomaly detection, and associative rule learning. So when it comes to clustering, clustering is a technique in which data points are grouped together based on their similarities. The goal is to partition the data in and group them into clusters so that the data points within a cluster are more similar than each others in the other cluster. So you can see the example below. So original unclustered data. This is the unclustered data. If you see here, nothing, every data points are there, but based on the similarities, right? From this we'll be performing the pre-processing and etc. And from this pre-processing and training, and based on when we perform this clustering, right, we will be grouping it out. So some similarities are there. So when there is some similarities between the data points, then it will be getting grouped into green color, then to red color, then to blue color. So different. So totally in this particular data set, there are three types of similarities. It can be any type, any example you want, you can take. So based on those three similarities, it is grouping out. For example, let's take chocolates itself for your better understanding. So now this is my chocolates data set. There are only three chocolates. One is Kit Kat, and one more is Dairy Milk. One more is 5 star. So now my target is I don't have any output column. So I want it to be based on those similarities, right? For this particular three chocolates, the based on the flavor similarities or based on the ingredients used. So it will be like clustering. It will be clustered or grouped in between them. We are with the help of similarities, we are finding the output. Now you can take this green one as the 5 star. So whatever similarity ingredients are there in the data related to 5 star, that all data is here. And whatever similarities are related to Kit Kat, that is in this red. And for Dairy Milk in this blue. You're getting my point. For your better understanding, I'm telling you all this for now. Dimensionality reduction technique. Dimensionality reduction technique is used to reduce the number of features or variable in the data set. The goal of dimensionality reduction is to simplify the data while retaining as much as information is possible. So dimensionality reduction is nothing but you will not be losing the data. The main target of dimensionality reduction is not to lose the data. Here only you will be trying to reduce the dimensions, but at the same time you will be retaining the information. The information should be there. Those information should not be dropped down. Only some basic unwanted information you will be trying to drop, that's all. Nothing else is going to happen here apart from that. This is mainly helpful when you have large data sets and when your laptop or else your device, whichever you're using, is taking more time to work at that particular time. This will be helpful for you all. And even many of us we use because we don't need to train on large data sets. Sometimes the accuracy will be very worst. So at that time we have to use dimensionality reduction and we have to take only some features whichever is important and we have to retain them, and left some unwanted features we can drop them or else even we can try to use them, but the accuracy should be improved. The main target is our model should perform better. You're getting my point? So again, in this there are mainly two types: feature selection and feature extraction. These all for these things again there will be a separate videos. You can just have a look on this for now to have a better understanding. Then we have anomaly detection. Anomaly detection is a common task in unsupervised ML, which involves identifying data points that are significantly different from the majority of the data. And anomaly detection can be used for wide range of applications such as fraud detection, network intrusion detection, and equipment's failure prediction, etc. So for that, this will be helpful. Like credit card fraud detection is a project in which you can use anomaly detection. I'll explain you all about this a bit more. Associative rule learning. Associative rule learning is a technique in unsupervised ML that identifies interesting relationships and associate between variable in large data set. It is known for associative rule mining or market-based analysis. The goal of associative rule learning is to discover interesting patterns and correlations and relationship between the data without any prior knowledge or assumption of the variables. So this we don't use much in the industry, but you can have a look on this. But it will be very helpful for us when you are doing some stock market analysis or some stock predictions and etc. That time this will be very helpful. You don't need any prior knowledge of that particular domain or data, but you can try with this. Now let's directly move towards semi-supervised learning, the third type. Semi-supervised learning is a type of machine learning where the algorithm is trained using both labeled and unlabeled dataset. In traditional supervised learning, all the data is labeled, meaning that each data points has a corresponding output or target value. However, but in semi-supervised, what it happens, it will be having the subset, like it has both unlabeled also and the labeled also. So some common applications of semi-supervised learning include NLP, computer vision, and speech recognition. Here what happens, you will be having the target variable, and sometimes even you might require to use unsupervised method like clustering or some other techniques. So it is a kind of semi-supervised. It will be using both. After that, when it comes to the fourth topic, that is reinforcement learning, is a type of machine learning or else a technique you can say, which is focused on training an agents to make decision based on the environment. The reinforcement learning can interact with an environment and receive feedback from the following. and rewards it pushes. So mainly this reinforcement learning why we use, right? So for example, take example of a robot. For now I'll just explain you all the example. You can read the detailed topic about this particular topic. If you read, you will get it. But let me explain you an example for reinforcement learning for your better understanding. Take an example of a robot. So you will be having only some training data set to it. After that, you cannot provide any training to it, right? It has to learn by itself. The main target of reinforcement learning is to learn by itself, and it will be mainly used in application of robots, or when you want to, like, take an example of a self-driving cars, how it can normally take right left. It is based on the roads. Normally a cars will be having a 360-degree camera, and when you set it out, it will be going right in the roads. How it will detect it should take right left, and how it will detect that friend the car is there, or it should stop at this particular point. How it's going to detect based on the cameras and its own reinforcement learning. It will learn continuously. Whenever it gets a new data, it will learn continuously by itself. Normally other methods, what we used to, we already have a data, we used to train it, and based on the trained best model only it can perform predictions. It doesn't have any training ability, but here it will be having the ability to learn by itself. Best example is robot. How much you train it, how much you explain the things, and how much data you provide, based on that it learns and it improves itself. It might become more intelligent also, it might even become more aggressive also. But this reinforcement learning is very helpful, and it is more used in today's AI era. If you want, you can have a look on this in detail, and I would recommend to start learning the reinforcement learning. Once you are done with this, it will be very interesting for you all. So guys, that's all for this particular video. That's enough. If you know all these particular topics, right, basics about overview, you're good to go further. So guys, that's all for today's video. Do like, share and subscribe the channel. I'll definitely make more interesting videos, and let us move to coding soon when this theory is completed. Okay, so that's all guys. Bye bye.